Good morning, students. We have a new topic to discuss in study of gas laws today, and that will be Charles law, which gives a relationship between temperature and volume of a gas. So let us say temperature, volume, relationship in gases. Relationship in gases. So what is this? And this law or this relationship was given by another scientist, a great scientist called Charles, and based on this experiment or relationship, he formulated a law which is called Charles law. So according to him, volume of a given mass of a dry gas is directly proportional to its absolute temperature, keeping the pressure constant. So we can write the Charles law as follows. Charles law, volume of given mass of dry gas is directly proportional to its absolute temperature absolute temperature keeping the pressure constant. Keeping the pressure constant. That is, at constant pressure, V is directly proportional to absolute temperature. It is at constant pressure. So he performed an experiment. Okay, when he found that the volume of a gas increases by 1 upon 273 times for every 1 degree rise in the temperature of a gas. So using that, he got a relationship between volume and the absolute temperature. So let us see what he concluded from his experiment to find out how many times will the volume increases. We have one more law that also can be written, which also gives a relationship between volume and temperature of a gas. So let's see. But remember, this is the main law and this is the expression of Charles law, a mathematical expression of Charles law. But as I said, he performed one experiment to find out what number of times will the volume increases, and then he found that it is always increased by 1 upon 273 times for every 1 degree rise in the temperature. So based on that experiment, we will see how he derived the Charles law. So we have another way to write the statement that for every 1 degree rise in temperature, of a given mass of dry gas, volume increases by 1,273 times the volume at 0 degree Celsius. Pressure remaining constant. Pressure remaining constant. So you can see for every 1 degree rise in temperature, the volume increases by 1 by 273 times the volume at 0 degree Celsius. Now we'll use this experiment to derive the Charles law. So let us see how can we do it. We can write derivation of Charles law. Charles law. Okay. So we have let volume of gas at 0 degree Celsius is equal to V0. Now let us suppose when we increase the temperature by T degree Celsius, you know we'll be getting a new volume. So we have volume of gas at T degree Celsius is equal to V0 plus 1 by 273 into V0. This is the number of times that it will increase by, multiplied by the temperature by which it has been risen. So we have got this, and we can take this new volume of gas as capital V. That means we can write V equal to, so let me write from this side, we can write V equal to V0 plus V0 into T divided by 273. So we can take out common and we will get 1 plus T by 273 left. Where we can also write, take the LCM 273 to get 273 plus T. Now as we know that when we add 273 to degree Celsius, where we have taken T in terms of degree Celsius, then this will be converted into an absolute temperature, that is temperature in Kelvin. So we can write V0 into T upon 273. This is the volume. Now as we know, volume at 0 degree Celsius and 273 are constant. So we can further write V equal to a constant into T. Once again we will take V0, a volume at 0 degree Celsius is constant and 273 is also constant. So we can take these two as constant multiplied by T. Now this can remove, or we can remove this constant one, and in place of that we can put a proportionality sign. So we have what V is directly proportional to absolute temperature. This is the derivation of Charles law, and we will now see the Charles law equation. So since we know according to Charles law, we know that V is directly proportional to T at constant temperature. So we can write V is equal to a constant into T, that is V by T is equal to constant. Here we can further write V by T1 is equal to V2 by T2, and this is called Charles law equation. This is Charles law equation. So I hope it is clear. Next class we'll solve some numericals based on Charles law. Thank you.